I'm going to go over the worksheet on our density practice problems that we had for homework. If you did poorly on this, you can check PowerSchool to see if you did poorly on it. And you can also go to your submission to see which ones you got wrong. You are welcome to open up your document and make corrections. You're going to want to make sure that you understand how to do all of these problems because you do have a quiz that includes density for tomorrow, as well as the rate of those reactions. So for problem number 3, it says salt water with a density of 1.13 grams per milliliter has a mass of 765 grams. What is the volume of this sample? So we want to solve for volume. So there's a couple of ways that we can do this. First, we could use algebra and solve for our unknown, which is the volume. So density is equal to mass divided by volume. And then we can solve for the unknown by solving for x. The other method that we can do is we can set up our triangle with density is equal to mass over volume. And when we have that triangle with density is equal to mass over volume, we can figure out, well, how do we calculate volume? So in terms of volume, we can look at that triangle and determine what the equation would be for calculating volume. And so then we can plug the numbers in to solve for number 3. So if I solve this using algebra, I would have to isolate my v. So I would multiply both sides by v, so it cancels out over this side. So I get 1.13 times our unknown volume is 765 grams. Divide both sides by 1.13 so that my volume is equal to 765 divided by 1.13. So you can see that both methods give you the same kind of algebra that you're doing. So 765 divided by 1.13, you should get a volume of 677. Don't forget units. Notice our grams or our density is in grams per milliliter, so our volume must be in milliliters. For the next problem, I have a mass of 37.92. So I'm going to go ahead and fill this in, 37.92 grams. And it says that I'm dropping it into 55 milliliters of water. And the water level goes up to 68.2. So this is a displacement method to find the volume. And so because we're using displacement, we're going to have to figure out the volume. So the volume is going to be the 68.2 milliliters at the end minus the 55 milliliters that we had at the beginning. So our volume is going to be 13.2 milliliters. So I can fill that in for my volume. Now that I have both pieces, I can simply use that density equals the mass over the volume. So I'm going to take my 37.92 grams and I'm going to divide it by the 13.2 milliliters and make sure that your answer is in grams per milliliter. So 37.92 divided by 13.2 gives us a density of 2.87 grams per milliliter. Problem number 5 says to use the water displacement method to determine the density of the object. So our initial water level in the graduated cylinder is 25 milliliters, and after we put the silly putty into the graduated cylinder, we get 29 milliliters. So again, our volume is going to be the 29 at the end minus our starting 25, which means our volume is 4 milliliters. So I'm going to go ahead and put that into my data table. And then we have the mass of our silly putty as 8 grams. So again, density is equal to mass over volume. So we can take our 8 grams and divide it by our 4 milliliters. So we want to make sure that we have our units as grams per milliliter. On number 6, it says, what is the mass? So this time, we're going to have to find a different piece. It gives us our density. It says our density is 0.89 grams per milliliter. So that's a little clue for us that mass is going to be in grams. And it tells us that it's going to displace 200,000 milliliters of water. So our volume is 200,000 milliliters of water. So density is equal to mass over volume, but we don't want to find density. So I'm going to use my triangle. Density is equal to mass over volume. And so if I want to find my mass, then that means I'm going to do density times volume. So mass is equal to density times volume. I can also rearrange this equation if I wanted to, or I could just do the algebra. So if I do the algebra, 0.89 grams per milliliter is equal to an unknown mass over a volume of 200,000 milliliters. If I want to solve for x, I would multiply both sides by 200,000 so that the 200,000 on this side cancels out and I'm left with just x. So 200,000 times 0.89 will give us our x. Now, if I set it up this way, my mass is my unknown. My density is 0.89 grams per milliliter, and my volume is 200,000. So you can see that mathematically, we end up doing the same exact thing. So 0.89 times 200,000 is going to give us a mass that is equal to 178,000 grams of ice. The next problem says that if gold costs 379 dollars per gram, and a wedding band has 7.56 centimeters cubed of gold, what is the mass? So we are going to have to look up the density of gold. So first thing, let's pick out some of the pieces of information we have. We do know the volume, and the volume is going to be 7.56 centimeters cubed. Remember, volume is length times width times height, so that's how we get centimeters cubed for this volume. If we were to use the displacement method, our volume would have been given to us in milliliters. So we need to calculate the mass of this gold and how much it cost. So first, let's find the density of gold on the internet. So according to the internet, the density of gold is 19.3 grams per centimeter cubed. We know we have a volume of 7.56 centimeters cubed. So we want to find the mass so that way we can figure out how much this particular wedding band would cost. So to solve for density, it is mass over volume. Well, we want to solve for mass. So we can rearrange this, algebraically multiply both sides by the volume so that volume cancels out. So we're left with volume times density equals our mass. We could also use our triangle. Density is mass divided by volume. So if we're finding our mass, we can see that mass is going to be equal to density times volume, just like we did algebraically here. So now I'm just going to plug in my numbers. So I have a volume of 7.56 centimeters cubed. I have a density of 19.3 grams per centimeter cubed. And so I'm going to be able to find my mass by taking 7.56 and multiplying it by 19.3. So the mass of this particular wedding band is 145.908 grams. I'm going to keep all of those digits so that I can calculate how much this wedding band cost. So it says that gold cost $379 per gram. Well, I know that this wedding band is 145.908 grams. So 1 gram is going to cost $379. So in order to figure out how much money this cost, I'm going to multiply 145.908 times $379. And this wedding band cost $55,299.13. The last problem, we have to use the displacement method in order to find the volume of each material. So we can see that our starting volume in our graduated cylinder is 75 milliliters, and our final volume in our graduated cylinder is 90 milliliters. So if we want to find the volume of our star, we would need to do 90 minus 75. So that will give us our volume of our first star. So 90 minus the 75 is going to be a volume of 15 milliliters. Now we can calculate density by taking our mass and dividing it by our volume. So our mass of this one is 60 grams, and we're going to divide by a volume of 15 milliliters. So 60 divided by 15, that gives us a density of 4 grams per milliliter. Don't forget your units. Our last problem has us start with a volume of 55 and end with a volume of 85. So we start with a volume of 85, we finish with a volume of 55 or 85. We started with 55, so that means that the volume changed by 30 milliliters. Our mass is going to be 10 grams. So we're going to take that 10 grams and divide it by our volume of 30 milliliters. So if we take 10 and divide it by 30, we get a density of 0.33 grams per milliliter for our last problem.